class, here's your promised video, lesson 40. It's the quotient rule for exponents. Quotient rule for exponents isn't that hard, but it's a different kind of concept. And then we have the distributive property of rational expressions that contain negative exponents. So it's a good thing you'll be able to rewatch this video if I'm going too fast. Again, remember how I said in class that you should try the examples and then pause the video, try the examples, and then check your solutions. So let's get started. So the beginning of this is just a review. It's a definition. If you have x times x times x times x dot 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 times x, it's going to be x to the n power. So it's as many x's would be the exponent. So if we have x times x times x, that's 3 x's, so it's going to be x to the third. If we had 5 x's, it'd be x to the fifth. The product rule is a really important one. If you have x squared times x to the third, if the bases are the same, whether they're variables or numbers, you're going to add the exponent, so it's going to be x to the fifth. If you had 2 to the fourth times 2 to the fifth, the bases are still the same, so you're going to get 2 to the ninth. So as long as the bases are the same, you can add exponents. Just clean that up a little bit. Okay, the next one's a definition. If you have, it's hard to see that, but if you have x to the first power, it's just going to equal x. So if you had 2 to the first power, it's just going to equal 2. So whatever is to the first power, it's just the number itself, the base. The next one is if x is not 0, then x to the negative n is 1 over x to the n. Remember, if you have x to the negative 2, you can just move it to the top, to the bottom, so it's going to be x squared. And if you had something like 1 over x to the negative 3, you would move it to the top and it would become positive. So that's just a definition. And the final one that's a review is if we have x to the 0 power, anything to the 0 power, y to the 0 power equals 1, 3 to the 0 power equals 1, anything to the 0 power equals 1. Now, finally to the quotient rule. The quotient rule says if m and n are real numbers and x does not equal 0 because you can't have 0 in the denominator, then you're going to subtract your exponents. So, so we have x to the, if we had x to the 5 over x squared, that's going to equal x to the 5 minus 2 power. So you're going to subtract your exponents, and you can either subtract them and put them in the numerator, so that would be x to the third, or if you want to put them in the denominator, you could say 1 over x to the 2 minus 5 power, which would be 1 over x to the negative 3 power. And you can see how these two things are the same. One is you're just moving it to the denominator and making it negative. So you can go either way. This is what this rule is saying. You can either take m minus n and put it in the numerator, or n minus m and put it in the denominator. So we're going to do plenty of examples so that you'll have practice with these. So they're going to tell you where to put your answer, and you have to do what they say. So the first one says simplify, write the answer with the x in the numerator, which means we're going to subtract m, which is the top, from n, which is the bottom. They should have called them, instead of m and n, maybe numerator and denominator, n and d, but we're going to go with it. So we're going to simplify. Now the quotient rule says that we're going to subtract the exponents. So this is going to be x to the 6 minus 4. Obviously I'm doing these and you didn't even need to pause the video because these are a new concept. I'll tell you when to pause it. So you get x squared. Now this is the same thing. If you want to think of it differently, we could have said x to the 6th times x to the negative 4, because if we bring it to the numerator, it becomes negative, which would still be x to the 2nd. But I want you to try doing it with the quotient rule where you subtract your exponents when you divide. So let's try the next one. It says simplify, write the answer with the x in the denominator this time. So to do it in the denominator, you're going to put a 1 over x to the bottom one minus the top one. So we're going to get 1 over x to the negative 2 power, like that. So that's the two ways you have to do what it says, numerator or denominator. Now the next one says simplify. It doesn't say where to put them. So let's put them in the numerator, and I want you to try this. Pause the video and see if you can put all the x's in the numerator. Pause it and come back. Okay, hopefully you paused it. So we're going to get x to the 6 minus a minus 4. So that's going to end up being x to the 10th power. So you're subtracting negative 4, so it's going to be the same as plus 4. We could have put these in the denominator. If it said put them in the denominator, it would have been 1 over x to the negative 4 minus 6, which would be 1 over x to the negative 10th power. Okay, the next one just says simplify. It's not telling us where to put them. This is x to the negative a over x to the b. Put them in the numerator, pause the video, and come back when you're done. Okay, hopefully you did it. So we get x to the negative a is already in the numerator, and we're going to subtract the denominator. So that actually is your answer because you can't combine them because they're not like terms. So I still subtracted them. If we wanted to put them in the denominator, it would be 1 over x to the b plus a, because it would be minus a would be plus a. All right, let's do the next one. This one has multivariables. Pause the video. I want you to put them all in the numerator. So go. Okay, hopefully you paused it. So we're going to get x. It's going to be negative 5, and down here is a 1, so it's going to be minus 1. Then we'll go to our y's. Y, we have 6 in the numerator, and y, we have 2 there, so it's going to be minus 2. And then we go to our z. We have 1 in the numerator and a minus a negative 3 when we bring it up. We're subtracting whatever it is. So we clean it up. We're going to get x to the negative 6, y to the 4th, z to the 4th. Okay, oops, did I get that right? Yeah, okay. And that is how we do the quotient rule. So you're going to have to say, I'm going to see if the examples tell you where to put them. Yeah, the examples say, on your practice problems, say put the variables in the numerator. So we'll be moving them all up to the numerator. That's it for that kind of example. So if you need to watch that again, feel free to rewind. We're going to go on to the next page, which is we're going to use the distributive property to expand. There are 3 of these examples. It says use the distributive property to expand, write the answers with all the exponents positive. Okay, this is another way they might say it. They might say make them in the numerator, make them in the denominator, or make them all positive, or make them all negative. So we've done these before where we're going to multiply this times this and this times this. This time we have negative exponents. This is going to make it more complicated. So we have 4 times, now we have x to the negative 2, x to the 2nd, so it's going to be x to the 0. I'm just going to write that. Y to the 4th. And then in the denominator, we have y to the 4th because this is over 1. So we're multiplying that together. All right, now we're going to multiply the 4 times the 3, and we get 12. We have x to the negative 2, x to the 4th is x squared. And this is all going to be over y squared. Making all the exponents positive, in this case, isn't that bad because they're already positives. All we have to do is simplify. X to the 0 is 1, so we can just kind of cross out because we're multiplying. And then y to the 4th will cross out with y to the 4th. So we're going to get 4 minus 12x squared over y squared. And that's your final answer to that. Okay, they're all positive. That one just turned out pretty good. Okay, this one says use the distributive property to expand, write the answer with all the variables in the numerator, which is what we did in the last example in the other part. So we're going to distribute this times this, and this times this. So we're going to get x to the negative 2, y to the 5th, because there's a 1 on there, and when the bases are the same, we add our exponents all over, and just think of this over 1 over x squared. And then we have x to the negative 2 times x to the 4th. I forgot to say pause the video. I hope you did that. If not, pause it now and see if you can get the last part of this one. All right, let's see what you got. So we get x squared, and we get y all over y squared. Now they want all the variables in the numerator, which means we need to bring the ones in the denominator up into the numerator. So we're going to subtract. So it's going to be x to the negative 2 minus 2 would be x to the negative 4. And then we have, we're going to subtract 2 from the 5. So we're going to get, whoops, no we're not. That just stays up there. And then we're going to have x squared. And then it's going to be y to the negative 1 power. And that is it. All the variables are in the numerator. All right, last one. You try it and then pause the video and then come back and see if you got it right. All right, we're going to distribute. So we have k. There's no other k, so we'll just write k squared. B to the 1 and b to the negative 1 would be b to the 0. And it's going to be a all over p to the negative 2, k squared, minus 4, always put the coefficient first, k squared, b, p, oops, blah, blah, blah. Okay, that would be b, not a p, and then p squared, all over p to the negative 2, b. Little complicated. These are a little bit messy. So we're going to simplify these. They want all the variables. Ooh, this is complicated. All the variables in the denominator. So we can cross this one out, b to the 0 power. So everybody in the numerator, there are no coefficients up here, so we're going to put a 1 to hold the place. K squared and k squared, they can cross out. It's like having 2 over 2. So we can just cross those out. And we're going to get a to the negative 1, p to the negative 2, minus, now the 4 is going to stay up here. It's not a variable, so it will stay in the numerator. We have p to the negative 2, p squared, so we're going to subtract 2 from negative 2, so we get p to the negative 4. These get really complicated. And then the b's are going to cross out, and then we have k to the negative 2 power. So that is how you do it when you have to put all the variables in the denominator. So these are rather complicated. We can go over these in class on Thursday, but give it a try. All right, so that is it for lesson 40.